Hello all. Now let us discuss about the important topic from electromagnetic waves, that is magnetic materials. Magnetic materials play an important role in electrical machines, transformers, memory devices, antennas and microwave engineering. So in this we will be classifying the magnetic materials and let us understand their behavior when placed in a magnetic field. So we will study the following magnetic materials: diamagnetic materials, paramagnetic materials, ferromagnetic materials, ferrimagnetic materials and antiferromagnetic materials. So each category has unique magnetic properties based on the arrangement of electrons and atomic magnetic moments. The first is diamagnetic materials. The diamagnetic materials are those materials which are weakly repelled by an external magnetic field. This behavior occurs because magnetic materials do not have permanent magnetic moments. When a magnetic field is applied, a weak magnetization is induced in the opposite direction to the applied field. The key characteristics of diamagnetic materials are: they exhibit weak repulsion when placed in a magnetic field, they do not possess permanent magnetism. Magnetism is induced only when external field is applied. Once the magnetic field is removed, the magnetism is immediately lost. So this means diamagnetic materials cannot retain magnetization. Some of the examples of diamagnetic materials includes elements such as copper, gold, silver, lead, mercury and bismuth, and compounds like water, most organic compounds such as plastics and petroleum, and other materials such as wood, diamond and graphite. So these materials are commonly used where magnetic interferences must be avoided. And the next one is paramagnetic materials. Paramagnetic materials are weakly attracted by an external magnetic field. This attraction is stronger than that of diamagnetic materials, but still relatively it is weak. The reason for this paramagnetism is the presence of unpaired electrons in their atomic structure. So the key characteristics of paramagnetic materials are: they show weak attraction to a magnetic field, they contain unpaired electrons which produces small magnetic moment. These magnetic moments are randomly oriented in the absence of magnetic field. When an external magnetic field is applied, the moments align with the field. Once the field is removed, this material loses its magnetism. Thus, paramagnetic materials do not retain magnetization permanently. The examples of paramagnetic materials are elements such as aluminum, titanium, platinum, oxygen, manganese, and chromium. And compounds involves transition metals and rare earth elements. And especially oxygen gases exhibit paramagnetic properties. So these materials are widely used in scientific and industrial applications. The next one is ferromagnetic materials. The ferromagnetic materials, which are most important magnetic materials in engineering, ferromagnetic materials exhibit strong attraction to magnetic fields and this can retain magnetization even after the electric field is removed. So this behavior in ferromagnetic material is due to the presence of magnetic domains. The key characteristics of the ferromagnetic materials are: they show strong attraction to magnetic fields and it possesses permanent magnetism, and it consists of magnetic domains which align when a magnetic field is applied. They have a characteristic temperature called the Curie temperature. So above the Curie temperature, ferromagnetic materials loses their ferromagnetic properties. Some of the examples of ferromagnetic materials are iron, cobalt and nickel, and alloys includes steel, alnico and permalloy, and compounds such as magnetite and satin ferrites. So these materials are widely used in motors, generators, transformers and magnetic storage devices. The next one is ferrimagnetic materials. The ferrimagnetic materials are similar to ferromagnetic materials, but the magnetic moments are unequally aligned in opposite directions. So as a result, they exhibit net magnetization, but it is less than that of ferromagnetic materials. The important characteristics of ferrimagnetic materials includes spontaneous magnetization, unequal alignment of magnetic moments, presence of a Curie temperature, high electrical resistivity which reduces eddy current losses. So because of their high resistivity, ferrimagnetic materials are widely used in high frequency applications. So examples of ferrimagnetic materials includes magnetite Fe3O4, ferrites and then garnets. So these materials are commonly used in microwave devices, inductors and transformer cores. The next one is anti-ferromagnetic materials. So in anti-ferromagnetic materials, the magnetic moments are equal in magnitude and aligned in proper opposite directions, resulting in zero net magnetization. The key characteristics of anti-ferromagnetic materials includes zero net magnetization, presence of characteristic temperature called the Neal temperature, low magnetic susceptibility, strong exchange interaction between neighboring atoms. Above the Neal temperature, anti-ferromagnetic materials behave like paramagnetic materials. The examples of anti-ferromagnetic materials includes chromium and manganese, and compounds like manganese oxide, nickel oxide, and iron oxide, and alloys such as iron manganese alloys. So these materials are used in magnetic sensors and spintronic devices. So magnetic materials are classified into five major types. So each type behaves differently in a magnetic field. Ferromagnetic and ferrimagnetic materials are most important in engineering applications. So understanding these materials is essential for studying electromagnetics and modern electronic devices. Thank you.